All right, welcome to lesson number 2, horizontal and vertical translations, part 2. What we were looking at yesterday was replacing our k and h values. And so remember that your k values are going to be the ones that act on your y, and the h values are the ones that act on your x values. And so if I have y minus k, that's going to describe a vertical translation. And we would write that in the form of y is equal to f of x plus k, where f of x is our function. And replacing our value of x, or not replacing it, but if we have a factor of h, that's going to change the parameters on our x values. And that will describe a horizontal translation. And remember, that can be, that horizontal translation and vertical translation could be up or down or left and right. So if I have a k value that is greater than 0, then the graph would move up. If it's less than 0, it would move down. And likewise with my h value, if it's greater than 0, then it's going to move to the right, and if it's less than 0, it's going to move to the left. Okay, so let's look at example number 1. If I have y is equal to x, x to the power of 4, and y is equal to x to the power of 4 plus 3, then this 3 here, this is going to be a result in a vertical translation. Because this is value, I could have it acting on my y, in which case I could make it look like this is equal to x to the power of 4. And so if I have x to the power of 4 plus 3, this is going to be a vertical translation. Vertical translation 3 units up. On the next question here, 6, my original function is y is equal to 6x minus 3. And I'm going to change that by making it y is equal to 6 times x minus 1 minus 3. Now what I have here are two transformations taking place. The first transformation, since this value of 1 is acting on my x value, this is going to be a horizontal translation. And, sorry, there's only one translation occurring here because this negative 3 is part of my original equation, but this is going to be a horizontal translation 1 unit to the right. So all I did was I took this x minus 1 and I replaced my value of x here. Alright, let's look at part C. Now I have two transformations occurring. I have my transformation on my absolute value of x, so it's absolute value of x minus 6, and I also have a vertical translation, positive 2, and so that's going to be 2 units up. And since it's minus 6, this is going to be 6 units right, and 2 units up. And for part D, I'm back to just one translation occurring, and that's going to be horizontal. And since it's plus 1, that's going to be 1 unit to the left. So write the replacements for x and or y and the equation of the image. So what we want to do is, using this information here, we want to make our new equation. So if I have a horizontal translation of 3 units to the right, this means that on my x value, if I go from x, this is going to change my x value to x to the right, x minus 3. So my new equation is going to look like this. Y is equal to x minus 3 squared. Now it won't be x squared minus 3 because that would result in a vertical translation 3 units down. Alright, so there is a difference between x minus 3 squared and this, which is y is equal to x squared minus 3. This would result in a different type of translation. This would be 3 units down, so it can't be this one. So y is equal to 10 to the power of x after a vertical translation of 2 units up. Now we're looking at the translation of my y value. Since it's 2 units up, this would result in y minus 2 is equal to 10 to the power of x, which, if I rewrite this equation, y would equal 10 to the power of x plus 2. And for part C, square root of x after horizontal translation of 4 units to the left. So 4 units to the left, this would have to be x plus 4. And for my y value, 3 units down, this would be y plus 3. And when I plug all these into my equation, I'm going to be left with y plus 3 is equal to the square root of x plus 4. Or we could rewrite this as y is equal to square root of x plus 4 minus 3. And you couldn't see any of that, could you? Sorry, there it all is. So the first thing we looked at was the parameters that were changing on my value of x. And then if I had a horizontal translation of 3 units to the right, I was going 3 units to the right of x, and so the 3 is acting on my value of x and not on x squared. If I had that parameter on the x squared, remember that would be a change in my value of my y's, so that'd be a vertical translation. Next, what I did was, if I had a vertical translation of 2 units up, remember that was a change in my values of y. 2 units up on the y would be minus 2. When I bring it over, it would become 10 to the power of x plus 2. And then on the third one was just a vertical translation of 3 units down and 4 units to the left. And so the resulting equation, if this is my function of square root of x, the resulting equation would be x plus 4 minus 3, where this positive 4 is acting on my value of x, which means that's going to go left 4 units, and then it's going to go down 3 units because that's what's acting on my y value. Okay, now what we're doing here is we're given an equation, and I'm just going to highlight the equation that is the original function for each of these. This is my original function. This here is my original function. This is my original function, and this is my original function. And so what we want to do is write an equation represented by our thick line. Okay, so from our highlighted line, we're going to our thick line. So if I'm looking at this first function, it looks like that if this is where I'm starting, then I'm going to be translating 2 units to the right here. Okay, so that's 2 units right, and it looks like 1, 2, 3, and 4 units down. 4 units down. And so from this equation, what that looks like, it's going to be y is going to equal the absolute value of x, and since I have a value acting on my value of x, this is going to become x minus 2. And then, so I have x minus 2, and then I have 4 units going down, so that would be x minus 2, absolute value, and I know it's 2 units down because I move to the right 2 units, and then I go down 1, 2, 3, 4 units. And so that would be a value acting on my y. Alright, so another way we could represent this is x minus 2, and then my value of y, and y plus 4. Alright, let's look at my next function. So let's say these are my data points here, and here I really only need to look at one, but if I look at this point here, it moves from here to up here, and so I'm going 1 unit right, and then it looks like I'm going 1, 2, so I go 1 unit right and 2 units up, which means that if this was acting on my x value, this would become x minus 1, and this would be 2 units up, y minus 2. And so that's what we're going to do. We're going to have our original equation, which is y is equal to 1 over x. So if I put these parameters onto my old equation, remember this would be y minus 2 is equal to 1 over x minus 1. And so my new equation, if I add to the other side, y is going to be x minus 1 plus 2. And I should put these in boxes so you know what the final answer would be. Now for my next equation. It looks like if I'm starting here, I'm going down 1, 2, 3, 4 units. And so that's going to be acting on my value of y plus 4. And so my initial equation was f of x. And so my new equation is going to become y plus 4 is equal to f of x. And so if I bring that for the other side, f of x minus 4. And my last equation looks like there's 2 parameters that are being changed from here. Looks like to go from here, I moved 1, 2, 3 units to the left. Okay, so 3 units left, and 1, 2, 3, 4 units up. 4 units up. And if y is equal to f of x, then 4 units up would be y minus 4 is equal to f of x plus 3. My final equation would be f of x plus 3 plus 4. Now, y is equal to square root of x, and it's a radical function. What vertical translation would be applied to y is equal to square root of x so that the translation image passes through 16 and 7? So what I want to do is, I know that I'm looking for my vertical translation. So if I have my vertical translation, remember that's something that acts on my y, and that would be in the form y minus k. And if I know that y minus k, in this case, y minus k is equal to the square root of x. And so all we do is we replace our values of y and x with our points of 16 and 7. So 16 is my x value, 7 is my y value. This is going to become 7 minus k is equal to the square root of 16. Now we solve for k. K is going to equal 7 minus k is equal to 4. Solve for k. If I bring 4 to the other side and k to this side, we're going to get k is equal to 3. And so this tells us that this is going to be a vertical translation. 3 units up. And I know it's going to be 3 units up because if I have y and acting on my y is my negative 3, and if I bring this to the other side, then we're going to have absolute value, or sorry, not absolute, square root of x plus 3. And so minus 3 is equal to the square root of x plus 3. Now, we'll do the same thing for part B. What horizontal translation would be applied to square root of x so that translation image passes through 17 and 8? Well, exact same thing. We're looking for the horizontal translation, so that's going to become x minus h. And we're going to do the exact same thing. We're going to replace our value of x, or not replace it, but we're going to add our parameter onto h and then replace it. So remember, this is our x values and this is our y values. And so 8 is equal to 17 minus h. Now I want to get rid of the square root here, so I'm going to have to square both sides. So I square that side and square this side, I'm going to get 64 is equal to 17 minus h. Subtract, or put h the other side, and subtract 64 from 17, you're going to get negative 47. And so if we plug this into our equation, x minus h, and if we plug minus h here, it's going to be plus 47. This is going to be a horizontal translation of 47 units to the left.